For 30 years, an entire generation of marine engineers believed they had solved the future of water travel completely. They built boats that did not float in the normal sense, lifted bodily out of the ocean by submerged underwater wings. These vessels skimmed across waves at twice the speed of any ferry afloat. The physics worked exactly as promised. The boats flew just inches above the water instead of above the clouds. Then, almost quietly, they vanished from service. The engineering was never the problem. What went wrong is a story the industry did not want to say out loud. To understand why this technology mattered, you must understand what every boat fights the moment it starts moving. A conventional hull sits fully in water, every inch of its bottom in constant contact with the ocean, creating drag. That resistance is the reason most ferries top out around 20 miles per hour, regardless of engine power available. Think of dragging a dinner plate through a full bathtub. You feel the water piling up, pulling hard against your hand. Now lift that plate so only its rim touches the surface, and drag it again. Resistance almost completely disappears. That is the entire idea behind a hydrofoil, except the plate is a 40-ton passenger ferry moving at speed. The underwater wings work on the same principle as an aircraft wing, a pressure difference producing powerful upward lift. Below 15 miles per hour, foils do nothing useful. Then, past that threshold, lift builds suddenly and the hull rises. Drag drops by roughly 70% in seconds. On the same engine power, the boat now crosses water at 45 miles per hour. The Boeing jet foil carried 250 passengers on foil assemblies, roughly the size of a large dining table. The Soviet Union built the Raketa-class hydrofoil from the 1950s and eventually ran more than 400 across vast waterways. Italy, Hong Kong, the Canary Islands, the Adriatic, the English Channel, every major maritime nation reached the same conclusion. On fast, short to medium routes with heavy passenger demand, the hydrofoil was the obvious and undeniable answer. Then the water started winning. The ocean is not a clean environment, and 45 miles per hour means highway speed impacts. A piece of driftwood that a normal hull barely notices becomes a structural event when it strikes a foil assembly. A single bad strike could put a boat out of service for days. Operators learned this repeatedly and expensively. Biological fouling made things worse invisibly. Barnacles and algae built up on wing surfaces, disrupting the lift-generating flow. Keeping the foils clean meant hauling the boat out of water on a schedule conventional ferries never required at all. The wave problem was not just uncomfortable, but operationally dangerous in a very specific and unpredictable way. A large wave hits the foils unevenly. The windward foil loses lift while the leeward foil bites deep, and the boat rolls hard. Hydrofoil routes were canceled for weather at rates that surprised even operators who had studied conditions carefully beforehand. All of this pushed maintenance costs into territory ferry operators had never budgeted for in any previous planning. A conventional hull is simple and rugged, with nothing moving below the waterline. A hydrofoil is a precision instrument. On the jet foil, hydraulic systems adjusted foil angle constantly and were deeply unhappy about prolonged exposure to salt water. There was also a hidden cost inside the speed itself. Fuel consumption at 45 miles per hour is extraordinary. The engines worked constantly not just to maintain speed, but to maintain altitude. There is no efficient middle setting. A hydrofoil is either flying or it is wallowing. On routes with swinging demand, running half-empty is financial disaster. Operators learned this the hard way across dozens of routes through the 1970s and 1980s, right when it mattered most. Then, in the 1980s, the high-speed catamaran arrived. 2 narrow hulls, wide deck, aluminum construction, water jet propulsion. Top speed was 35 to 40 miles per hour, close enough to satisfy passengers, and dramatically simpler to maintain. No foils, no hydraulics, no debris vulnerability. The catamaran operated in sea states that would have grounded any hydrofoil. The catamaran did not win on raw speed. It won on every other line in the spreadsheet that mattered. Fuel cost per passenger mile, maintenance hours per crossing. Weather cancellation rate, useful life before overhaul. The numbers told the story. One by one, operators ran the numbers and reached the same conclusion. The faster machine was losing every other comparison. By the late 1990s, most commercial hydrofoil passenger services had been retired or quietly replaced by catamarans. The Hong Kong to Macau jetfoil route survived longer than most, kept alive by its particular operating conditions. The Soviets had largely abandoned their river hydrofoil fleet as post-Soviet economics made operating aging vessels impossible to justify. But the hydrofoil did not disappear entirely. It retreated to environments where its speed had no cheaper substitute. The United States Navy still runs foil-derived systems on patrol and interdiction vessels, where 45 miles per hour is a tactical requirement. And in racing, America's Cup yachts now fly on hydrofoil systems, lifting the entire boat clear of water above 50 miles per hour, managing aerodynamic forces in the sails and hydrodynamic forces in the foils simultaneously, sailing and flying at the same time. The physics never changed. The application simply found the context where the trade-offs finally make sense. At last, the engineers of the 1960s were not wrong about what a hydrofoil could do. They were wrong about profitable routes. Speed on its own is not a product. Speed combined with reliability and bad weather capability is a real product. The hydrofoil delivered speed brilliantly while struggling with everything else. The water won through slow, relentless arithmetic, not through any single dramatic failure, but through operating costs, weather logs, and maintenance schedules repeated across hundreds of routes. The high-speed catamaran that replaced the hydrofoil has its own physics problem, significantly worse as hull length and speed increase. It comes down to how two narrow hulls moving fast interact beneath the surface, and what that does to the structure above. It is a problem the industry solved in a way that looks completely wrong until you understand exactly why it works.